Okay, up here on the board you can see molarity. Now, one thing before we get into our learning targets and success criteria is it's very important not to confuse molarity with molality. You're going to get the molality coming up later on this week. Okay? So, molarity and molality are two different calculations. And the only difference between the two is right here. One of them has an R there, one of them has an L there. So it's very easy to confuse these two. So make sure you know which one we are talking about, molarity or molality. Now, the learning target is to understand the properties that describe solutions in terms of concentrations, solutes, and solvents. What we are actually going to do is we are going to take the amount of a solute in moles, divide it by a certain amount of solution, which is the solute and the solvent together, making the solution, to give us a concentration in molarity. Now, you've dealt with molarity before. You probably just didn't know you were dealing with it because molarity is recognized by the label capital M. Okay, so we will recognize molarity as capital M. We will write the equation for molarity, and we will calculate moles, volumes, and grams of a substance using the molarity. Now, we did a lab earlier dealing with the molar volume of a gas, where I used a eudiometer and I demoed it for you at the back of the room. Now, when we did that, we used a hydrochloric acid that was 6M HCl. So what that means is that that was a 6 molar solution of hydrochloric acid. So that was the concentration. Now, likewise, when you did Computer Lab 13 last week, when you did Computer Lab 13, you used a hydrochloric acid that was 0.05 molar HCl. So compared to this one is a very, very diluted concentration. Okay? So you've been using these molarities. You just haven't recognized them as being a molarity because you didn't know what the M meant yet. Now you do. All right? Now you do. A lot of the times when we're doing labs, we have a certain molar concentration of the chemical. Okay? And pretty soon here, if I remember right, pretty soon you're going to be making your own chemicals to do your labs. Okay, because you will have that knowledge at your hands. Now, molarity. Molarity is equal to the number of moles of the solute divided by the liters of solution. Okay, so when we're looking at this in terms of labels, the molarity is going to be the moles over the volume, moles over liters. But don't put this, don't put this as your label. Always put the M, the capital M, as your label, okay, when dealing with the molarity. Here's our first example that we're going to work. Go ahead and write this down in your notes, and then we will work it. What is the molarity if one dissolves 21.1 grams of sodium hydroxide in enough water to make 2 liters of the solution? Now, we know that when we're calculating the molarity, that molarity equals moles of solute divided by liters of solution. Now, I have, right up here, I have 2 liters of the solution. However, do I have moles of sodium hydroxide? I do not. I have grams. But can I go from grams to moles? Absolutely. That's flux capacitor stuff, right? So the very first thing I need to do is I need to find the number of moles. So I'm going to need to take the molar mass of sodium hydroxide and set up a conversion box like this. So 21.1 grams of sodium hydroxide. My conversion box is 1 mole of sodium hydroxide over 39.99711 grams. So I get my grams to cancel here. I have now converted that into moles. You should have got 0.52754 moles of sodium hydroxide. Now, after I've got my value of moles, the next thing I need to do is find the molarity. And I know that molarity is equal to moles of solute divided by liters of solution. So I take the moles that I just calculated, and I divide it by the liters of solution, which is 2.00. So when I divided that out, I came up with a value of 0.264 molar sodium hydroxide. So what I've made there is a 0.264 molar solution of sodium hydroxide. Not too tough a math, is it? Now this one's a little bit different. Okay, this one's a little bit different. Go ahead and copy that down, and then we will work it. How many grams of potassium hydroxide are required to make 500 milliliters of a 0.282 molar solution? So what we're going to have to do here, folks, is we're going to manipulate our equation a little bit, because we're given a molarity and we're given a volume. Notice, mental note, my volume is in milliliters. Do I want volume in milliliters? No, I do not. I want volume in liters. So how do I get milliliters to liters? I jump my decimal 3 places to the left. Okay, so that's going to be 0.500 liters. So first thing I need to do is I need to find the number of moles by manipulating my equation. I know that the number of moles is equal to the molarity times the number of liters of solution. Well, I'm going to take the 0.282 and multiply that by 0.5 liters. And when I get my moles, I'm going to get 0.141 moles of potassium hydroxide. Now, that's not what I want, is it? What do I want? I want grams. So I'm going to have to flux capacitor this back into grams. So I need to find the number of grams by taking the number of moles I just calculated, and this is the molar mass of potassium hydroxide. So when I take that 0.141 and I multiply that by 56.10034, I get a value, well, I get a cancel, and I get a value of 7.91 grams. Now, I did not change this slide, okay, but yours should have a decimal point here. I'm going to have to go back and change this slide also. I didn't realize I had 2 different slides. So this 3 sig figs down here is correct because I've changed it on the very first slide. Okay. Any questions over this example? Okay, here's another one. Let's go ahead and write this one down, and then we're going to work it. What is the molarity if one dissolves 13.9 grams of ammonium bromide in enough water to make 150 milliliters of solution? Okay. What's the first thing, Tyler? What's the first thing I need to do here? I can convert the 150 milliliters into liters. Okay, good idea. I need to do that. Okay, what else do I need to do then? Cody? Convert the grams to moles. So I need to find what? I need the molar mass of ammonium bromide, right? So I need to, first of all, convert this into, moles. And I do so by this conversion box. I've already calculated that the molar mass of ammonium bromide is 97.94246. I get my cancellations. So now I have converted this into 0.14192 moles of ammonium bromide. Okay, Aiden, what's my next step then? I convert milliliters to liters. Yeah, we said that. What else then? Next, after I've done that, I need to find the molarity. So I'm going to use the equation what, Stephen? Moles of solute over liters of solution. My moles of solute was 0.14192 moles of ammonium bromide. My liters of solution I converted, so it's going to be 0.150 liters. So when I did my math, I came up with a value of 0.946 molar ammonium bromide. Any questions? Think it's easy enough? I hope, because here is your question. Go ahead and calculate this, and when you get done, bring it up to me so I can look at it to make sure that you have this done correctly. Once you have this completed, you are free to start working on WebAssign number 8.8.